Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Caliene, C7H6, is a cross-conjugated bicyclic molecule consisting of a cyclopentadenyl ring connected through a methane bridge to a cyclopropenyl ring. To determine which resonance form contributes most to the resonance hybrid, we apply Huckel's rule of aromaticity. Step 1. Identify the rings and electron counts. The 5-membered ring, cyclopentadenyl, if it bears a negative charge, gains 1 electron. It has 6 pi electrons, 4n plus 2, n is equal to 1, aromatic anion, cyclopentadenyl anion, Cp. The 3-membered ring, cyclopropenyl, if it bears a positive charge, loses 1 electron. It has 2 pi electrons, 4n plus 2, n is equal to 0, aromatic cation, cyclopropenyl cation, Cy+. Step 2. Evaluate aromaticity of each resonance form. Option A. Neutral, no formal charges, no aromatic stabilization from charge delocalization contributes but lacks extra aromatic stabilization. Option B. Charges are localized on individual carbons, not delocalized over the rings, so no ring aromaticity is achieved, poor contributor. Option C. Positive charge on 5-membered ring and negative charge on 3-membered ring. 5-membered ring with plus has 4 pi electrons, anti-aromatic. 3-membered ring with has 4 pi electrons, anti-aromatic. Both rings are anti-aromatic, very unstable contributor. Option D. Negative charge delocalized over the 5-membered ring, cyclopentadenyl anion, 6 pi electrons, aromatic, and positive charge delocalized over the 3-membered ring, cyclopropenyl cation, 2 pi electrons, aromatic. Both rings are simultaneously aromatic, giving maximum stabilization. This structure also explains why caliene is polar. Step 3. Conclusion. Option D achieves double aromaticity, an aromatic cyclopentadenyl anion, 6 pi, and an aromatic cyclopropenyl cation, 2 pi, simultaneously providing the greatest stabilization and thus contributing most to the resonance hybrid. This also accounts for the observed polarity of the molecule. Options A, B, and C either lack aromatic stabilization or introduce antromaticity, making them lesser contributors. Therefore, the correct answer is D. Therefore, the correct answer is option D.